Okay, so average rate of change is nothing new. That's simply the slope between 2 points. Okay, so when you get a problem, and there's going to be some problems that you're going to work on in this Math Excel assignment, they say, well, what is the average rate of change? We're working with linear functions, so the average rate of change from A to B would be the same thing from A to, if I had some other point here, C, because it's going at that constant slope the whole time. Okay, so even if I put some C in there, from A to C would be the same thing as what A to B is, but it's an average rate of change. Okay, so let's do an example. Find the average rate of change in the amount of money spent on R&D per year. So here's a little graph of Google spending on R&D. So we could see in 2009, they spent $2,800. So this is essentially my A, and this is F of A. In 2013, they spent $8,000, and it's actually in millions, so 8,000 million, 8 billion, I guess that would be. So B, and this is F of B. So the average rate, we're simply going to do our average rate formula, which was F of B minus F of A all over B minus A. So on this one, we'd have 8,000, subtract 2,800, all divided by 2013, subtract 2009. If we were to subtract, the numerator becomes 5,200, the denominator becomes 4. When we do this, we end up with 1,300. What are my units on this? What's this 1,300 in the context of this problem? What does this represent? Well, let's look back at our fraction. What were the units on this numerator right here? What were the units on that? Millions. What is the denominator? What do these numbers represent? The year. And so 1,300 is really 1,300 million per year as a dollar amount. Okay, the average rate of change, meaning when this one's an increasing function, so it's positive. So they increased 1,300 million per year in their spending. That was the average rate of change. Okay, and then we can have a negative average rate of change too. If this had been flipped, it started up here at 8,000 and went down to 2,800, we would get a negative slope. But in the context of a word problem, that still makes sense. If it's a negative, it means they've decreased spending. This one would have been increased spending each year. All right, linear models. So we're going to talk about 3 linear models dealing with money. That these are 3 equations that you need to know and you need to be able to work with. Okay, simply having them in your notes is fine. You don't necessarily have to memorize them. They're not anything crazy. But the first one we're going to talk about is linear cost. So talking in money, linear means it's going to be a straight line. We're going to work with the function c of x to represent cost is mx plus b. I mean, it's linear, so y equals mx plus b we know is slope-intercept form. That's for a line. So this one, instead of saying y, we're going to say cost, and c of x means that it's in terms of x. And now talking about tangible things. So in this case, x represents the number of items produced. M is the cost per item. and B would be some sort of fixed cost. So we're gonna work with word problems on these, and so we need to be able to identify, okay, this is the number of items, this is the cost per item, this is the fixed cost, and be able to put them back into our cost function. So fixed costs, that B value, are costs that do not change. For example, like cost of a building. Okay, it doesn't matter if I make 2 units or if I make 2 million units, my building is going to cost me the same amount of money for that month or that day or that week, whatever we're looking at. And then the M times X, that term will increase in value as more items are produced. Okay, if you think of labor's cost is going to increase if you're making more and more items. Material costs are going to increase if you're making more and more items. So those will change, but then that B is a fixed cost. Okay. We can talk about a revenue function. So sales, if I sell something, I earn revenue from that. So revenue as capital R of X, we can write as the function P times X, where P is the price of that unit and X is the number of items sold. So if I sell 5 items at $10, I know my revenue is $50. So it's pretty straightforward, but this is just a simple revenue function. And then profit, we're asked about profit. That's my revenue, how much money I'm bringing in, but then I got to take out my costs that it costs me to produce. So revenue is P of X. I'm sorry, profit is P of X equals R of X minus C of X. So I'll give you a second to write this down, because you need to be able to work with these, and we're going to do one example, and then I'm going to turn you loose to start working on the Math Excel. Okay, all right, so Dayton is looking to start a side hustle selling math textbooks. His fixed costs are $1,500. The cost to produce each book is $100, and each book sells for $125. Okay, so this setup we're going to use, and we're going to have A, B, C, D parts to this problem. So this is the initial information we're given. Part A, write a linear function to model the cost. And so that's one of our functions that we just wrote down. And we know that C of X is going to be equal to that M of X plus B, or sorry, M times X plus B. From this paragraph setup, what is B for this one? 1,500. So our cost function C of X, we know we're going to have this 1,500. Okay, so 1,500's rent on the building or whatever. It's the same. Okay, it doesn't matter if you produce one text or sell one textbook or if you sell 100 textbooks. The cost to produce each book is $100, and each book sells for $125. What is my M going to be? So remember, this is a cost function, and it costs $100 to make it. So $100 and X will represent my textbooks, or Dayton's textbooks. All right, so this would be a linear cost function for this scenario. Okay, if we wanted to set up the revenue function. Oh, sorry, go back to that. Go. So, no, I want you to speak up if I go too fast. Obviously, I'm not writing this down. All right, part B. Write a linear function to model the revenue. So again, revenue is P times X. So again, it's a function in terms of X. X is going to stay my variable. And in this case, the textbooks represent X. So I'll just write that down too. So again, textbooks are this X variable. So the revenue means sales, money that's being made on this. We can see here each book sells for $125. So it would be 125 times X. Sold one book, it'd be $125. Sold 10 books, it'd be $12.50, and so on. Okay, we're just creating the function. We're not calculating anything yet. Okay, part C, write a linear function to model the profit. So profit in terms of X, I'm going to take my revenue, however much money I'm making, but then I have to subtract out my costs to determine how much actual profit I take home at the end of the day. So on this one, we already figured out what R of X was. That was 125X. We already figured out C of X, and I'm going to put this in parentheses on purpose, because remember, it was 100X plus 1,500. So that whole expression was a cost. And so really this is 125X minus 100X minus 1,500. We can combine like terms from those. So we just end up with 25X minus 1,500. That is the profit function. So we can see one textbook is going to lose money. We could actually solve that, figure out how many textbooks would be the break even, or when we'd start making money. But that would be the profit function. Okay, so part D, how many must be, oh, this is supposed to be Dayton. Sorry, Dayton. I recycled this. Last year was Rocky, this year too. How many books must be sold for Dayton to make a profit? So again, our profit function we just found was 25X minus 1,500. We could find a break-even point. If he made $0, that would be the break-even. So I could say 0 equals 25X minus 1,500. So if I wanted to solve this equation, if I add 1,500 to both sides, I'm going to have 1,500 equals 25X. Divide each side by 25, divide each side by 25. I would end up X equals 60. So how many books must he sell to make a profit? 61, because again, this is the break even. So we need to be 61 or more to make a profit. So taking your final answer, into the context of the problem. And we're not going to have 60.5. We're not going to have half a textbook. We're dealing with whole units here. So 61 or more to make a profit. Easy enough, right? Okay, so day 2 in Math Excel, and this is the end of the material for the quiz for tomorrow. All right, so hopefully these first 4 sections weren't anything that was too crazy for you. If you have questions, obviously ask me so I can help clarify. This part 2 closes 12:07 tomorrow, so make sure you have it done prior to that. And then we'll take the quiz.